logarithmic functions. If a is greater than 0 and a does not equal 1, the exponential function f of x is equal a to the x is either increasing or decreasing, and so it is 1-to-1 by the horizontal line test. It therefore has an inverse function f inverse, which is called the logarithmic function with base a, and is denoted by the log of base a. If we use the formulation of an inverse function given by equation number 3, f inverse of x, which is equal to y, is equivalent to f of y, which is equal to x. Then we have formula 6, which makes the log of base a of x is equal to y, is equivalent to the base of a with exponent y is equal to x. So the best thing we can describe is that y is the exponent on base a to get x. So for formula number 7, these are the two formulas that you want to use in this class here. So if we have the log of base a to the x, which is equal to x. So the question is saying, what is the exponent on base a to get a to the x? Well, the answer is x, for every x that is all real numbers. And here we have a to the exponent of the log of base a of x, which is equal to x, for every x being greater than 0. So y is equal to a to the x has an inverse, and that inverse is y is equal to the log of base a of x. So this graph is when the base is greater than 1, and this is when the base is greater than 1. So you can see that these two functions are inverse of each other, with y equals x being the line of symmetry. Now, if you look at the base, so if we start out with the base of 2, okay, you can see it's rising a lot higher than the other ones. As you go with your base for a logarithm, as it increases to 3, you can see that the graph is actually flattening out. And then here, the log of base 5 is flattening out even more, and then the log of base 10 is also flattening out. Now, we also want to go over the laws of logarithms. So if x and y are positive numbers, then the first one we can say the log of base a of xy is equal to the log of base ax plus the log of base ay. Number 2, the log of base a with x over y is equal to the log of base ax minus the log of base ay. The log of base ax to the exponent of r is equal to r times the log of base ax, where r is any real number.